All right, 7.3, multiplying and dividing rational functions. All right, first thing we're going to do is simplify rational functions. And one of the key things you need to understand is what you're going to do is always, when you have a rational function to simplify, is to factor. Factor everything, numerator, denominator, factor as much as you can, factor completely, and then look to simplify by canceling things out. Now, what cancels out is monomials cancel with monomials, binomials cancel with binomials, trinomials cancel with trinomials. Monomials, can be just simplified, but binomials and trinomials have to cancel with the exact same binomial or trinomial. All right, and I'm going to kind of show that here, but factoring is a huge part in this. So if you did that factoring review, it should help tremendously. If you didn't and you need to go back and try it, I would suggest it, I guess. All right, here we go. What we're going to do is simplify number 1, and I have a trinomial on top, and trinomials factor to 2 binomials. So I am going to go ahead and make 2 parentheses there. It's going to be x, and it's going to be minus, so it's going to be a positive times negative. And can you think of 2 numbers that multiply to give you negative 12 that add up to give you negative 4? Well, it's negative 6 and positive 2. In the denominator, it's x squared minus 4, and that's what we call a difference of 2 squares. Perfect square minus perfect square. And that factors to x plus 2 times the quantity x minus 2. The exact same terms, but a different sign in the middle. Alright, and what I said before is that binomials cancel with binomials, and they had to be the exact same. So the x plus 2's simplify out. These are not the exact same, so there is our simplified solution. X minus 6 over x minus 2. Now, back to the denominator cannot be 0, right? Because that would be undefined. So I have to state those here, what would not be okay. And that's kind of what this is saying right here. So with the b cannot be 0 or c cannot be 0 because then it would be undefined. Now in this case, if I put negative 2 plus 2, that would give me 0. So x cannot be negative 2, and positive 2 plus 2 is 0. So it cannot be positive or negative 2. And that's our answer. The simplified version, and basically stating what cannot happen for it to be undefined. So there we go. There is number 1. Try number 2. I'm going to go ahead and show it to you here. So pause it. And there you go. Number 2. X minus 4 over x minus 3. X cannot be positive negative 3. Alright, scoot it on down. Multiplying. Multiplying rational expressions. We are multiplying fractions, just with polynomials. Alright, and what you can do when you multiply is multiply across and then look to simplify. But there isn't really a shortcut. And what we can do with multiplication is cross cancel. Alright, and I just try to cross cancel this as much as possible. And if I look at this first one, number 3, I see 8 on top and 2 times 4, which is 8 on bottom, and I am going to cancel out 8 divided by 8, which is 1. I also did the same thing with my x and y. So I got y cubed on the bottom. Look, y squared times y is y cubed. And I got a y cubed on top. So all those cancel out. Perfect. Now, I can't completely cancel out all this here. So maybe I multiply across there and then look to cancel. But I can cross out or cancel out that x right there. So I'll start on the top. Multiply across. And I get the 7x to the 7th power y over x right there. And now when I have like bases, I subtract the exponents. So 7 minus 1 is 6, and that will cancel that out and that out, make that 6. And now I have my answer, 7x x to the 6th power y. And that's it. Alrighty. Now, go ahead and give number 4 a try. And I'm going to go ahead and show you the answer. Voila. There is number 4. Hope you got that. Oh, I forgot to state what's not excluded there. Sorry. And we have x and y in our denominator, so x cannot be 0, and also y cannot be 0. Forgot about that part. Alrighty. Flip. Let me show this one more time. There's number 4. And flip. Okay. Same concept here. We are multiplying, except now we have binomials, trinomials. We're going to factor these out and simplify. So, here we go. I look at the top. I have a greatest common factor of 3x there. I'm going to pull out 3x. What do I have? 3x times what is 3x? 1. 3x times what is negative 3x squared? Negative x. Over. Factor the binomial to two numbers that multiply to give you negative 5. That add up to give you positive 4. Well, positive 5 and negative 1. So x plus 5, x minus 1 times 3x is going to go down there, and two numbers that multiply to give me negative 20 that add up to give me positive 1, x plus 5, and x minus 4. Alright, perfect. So now I'm going to look to simplify. So cancel stuff out. Monomial 3x, they simplified to nothing, or 1, really. 3x divided by 3x is 1. Okay, I have x plus 5 and x plus 5. They cancel out. Alright, and look at here. We have 1 minus x and x minus 1. And those are pretty close. And actually, I can simplify here if I factor out a negative 1. So if I factor out a negative 1, it becomes negative 1 and positive x. And if I write it in the reverse, x minus 1, now I have the exact same binomial, so I can cancel those out. Okay, so what do I have left? Negative 1 times x minus 4, and you could write negative 1 times x minus 4. I prefer to write it like this. 4 minus x, I distribute that negative 1 in there. And now I state what x cannot be. Well, x cannot be 0, because 3 times 0 would give me 0, and that's not okay. X cannot be positive 1, because 1 minus 1 is 0. And x cannot be negative 5, because negative 5 plus 5 is 0. Voila, we are done. Okay, try number 6. Give it a go, and I'm going to go ahead and show you this answer. Okay, there is number 6. You should get 2 minus x. X cannot be 0, 1, and 3. Alright guys, I'm going to keep on going. Multiplying rational expressions by a polynomial, it's the same thing basically, right? Exact same thing going on here, except this has a denominator of 1, right? So what I'm going to do is factor here. X plus 2 does not factor. But right here, x cubed minus 27, well, actually that's a difference of cubes. So how we do that again, if you don't remember, you can take the cube root of both of them, x minus 3. Then it will be take that first term, square it, multiply these terms together, and then times it by -1. So that's negative 3x times 1. -1 is positive 3x. And then you take your last term, -3 there, and you square it, and you get positive 9. Oops. Positive 9. Yoko. Alright, and now I'm going to multiply that times this x squared plus 3x plus 9 over 1. And now, what can I do? Well, I can just basically cancel out those parts. And I am left with my answer being x plus 2 over x minus 3. Right? Times 1 is still x minus 3. What can x not be equal to? Well, it cannot be equal to positive 3, and that's it. Because if I put 3 right there, I get 0. So, and this is nothing. Don't worry about that. So, voila. There is our answer there for number 7. Give number 8 a try. I'm going to show this answer to you. And there you go. Number 8. Quantity of x minus 7 over x plus 2, where x cannot be negative 2. Alrighty. Dividing. Same idea, right? So when we are dividing, we have division sign right there, and in order to get rid of that division sign, we do copy dot flip. You copy the first fraction, put a dot for multiplication, and then you take the reciprocal of the second fraction, you flip it, right? So it becomes, instead of c over d, it becomes d over c. And then we go back to multiplication, the exact same thing we just did. So really, nothing too crazy here. Let's give it a go. So, here we go. We have 7x over, and I'm just going to go ahead and factor that 2 out, and I get x minus 5. Greatest common factor is 2. Put a dot for multiplication and flip, and I'm just going to go ahead and factor at the same time. Two numbers that multiply to give me positive 30, that have to give me negative 11, negative 6, and negative 5. And then on the top, I'm going to move it down to the bottom, take out the greatest common factor, which is x, and I am left with x minus 6. Alright, look to simplify. Well, I can cancel out the x minus 6's. I can cancel out, cross cancel the x minus 5's. I can cross cancel the x's here. And what is left? Well, just 7 over 2. And done. What can x not be equal to? Well, it cannot be equal to 5. 5 minus 5 is 0. It cannot be equal to 0. And it cannot be equal to 6, because 6 minus 6 is 0. Scoot it on over there. There is our answer. And go ahead and try number 10. Give it a go. I'm going to show you the answer right here. Alright, and let me scoot out a little bit there. Alright, and there is all the work. Factored it, copied out, flipped it, and then simplified it. And then multiplied across. Alright, awesome. I'm going to have to stop this video here because I'm running out of time. And we'll flip it on back to the back page.